Hello everybody, welcome back. My name's Jace. This channel is about my efforts to build an N-gauge railway, and this is control panel part 4, I think. I'm going to try and do what I have to do to the control panel in this video now. So this hopefully will be the last video, but it might be a bit longer than the usual sort of half an hour. I'll try and condense it, but I don't want to skip things out that are relevant, obviously. So I'll grab the camera and I will show you where I'm at so far. So here we are. Right, in the last video I wired up the points, which are the white wires here. I'm having a bit of a problem with some of the switches. I've bought the switches from Amazon and I'm not convinced that they're great. I have had to replace a couple, and this one I've noticed just has broken the tabs off the back of the switch, just moving it around. That one, the solder's come off by the looks of it. Oh no, the tabs are still there. Okay, it's either my soldering or I need to make this cable set a bit longer so that there's less stress on the switch. Right. In previous videos I've showed you the resistor board, and I've now made a diode board for the other side of the LEDs, but I think I'm going to have to change this. But we are going to do an experiment next just to make sure I know which way around the diodes go. I think I've got half of these the wrong way round, and that's because I've been thinking about the way DCC works in the wrong way, and quite a few of you have said, Jace, it doesn't have a positive and negative. You need to stop saying that, and you're absolutely right. It's just I've worked on DC systems on obviously model railways, but also plant machinery and vehicles and industrial stuff for so long. If I see a red wire, I automatically think it's positive. It isn't in DCC. It's more, they kind of switch from one to the other really fast, as far as I understand. So from now on, I'm going to call them red and black, or try to. And because I was thinking that way, I put half of these diodes one way and half of them the other, because half of the black leads from the LEDs connect to the red DCC and half connect to the black. And therefore I was thinking the flow of electricity is different, but I don't think it is. And we're going to do this experiment just to confirm in my own mind which way round the diodes need to go. I've also made a board here with resistors on and diodes here, and that is for the LEDs that are permanently on. So this one, that one, I think there's a couple of others somewhere. So that's what they're for. I've got DCC coming in red and black, as I've said, 4 terminal blocks here, purely because I've got more connect to those than I have DC, which comes in over here, yellow and blue, to these 2, and then is going off to the circuit board for the potentiometer to control the turntable. So what we're going to do now is we're going to set up a point motor, a resistor, diodes, a way of switching it to prove which way these diodes should be fitted, and then I can crack on with the rest of the board. Okay, so we've got a few bits. We need a point motor, we need a couple of LEDs. This is my drawer of electrical bits. It's the storeroom. I've got track in this one. electrical in this one. I even take apart my lad's old toys, and just for motors and connections and things. So if you've got kids or grandkids, anything that's going to go at the tip, cannibalise it first. Okay, so what else do we need? We need a few wires. That's a green wire. We can use any colour just for the experiment. So, what's that one? That's not good. Okay, so let's see how we get on. So if I just disconnect, because we're going to need some DCC power for this. So I will take out that red and that black. Okay, so I'll explain this little setup. We've got, I'll move things across so you can see. So we've got DCC power, red and black, on these two Wagos. We've got this wire going to feed the point motor on, so terminals 1 and 2 are DCC in. So we've got the red and we've got the blue to these two Wagos as well. Out of terminal 3 of the point motor, we've got this green wire that comes down to this board, which has got one resistor on it, so that I'm reducing the power from 15 volts down to 12 volts to suit my LEDs, and also the current from about 2 amps hopefully down to about 20 milliamps to suit the LEDs. So that's all that is. And then both LEDs, the green wires, are attached to the resistor, and then one of the black wires goes along through a diode that allows power that way back to the DCC bus, and then the other LED black wire goes through a diode allowing power that way to the other DCC wire. And that's the wiring for it. So if these three wires here are basically the switch wires. So the green is the live, and then we've got a switch one way on this wire and one way on that wire. If I now touch the yellow wire to the green wire, the point motor should move across, and this LED should go out and this one should come on. And there we go. So I've just proved to myself that the diodes should be fitted in the direction of the DCC bus. So power is coming down the black wire that way into the DCC bus on both of them. And that means I've built half of my diode board the wrong way round. So I'll take it back out again then and redo it. And so what you can see on the back of the board here is there's all the diodes. And if you can see there, you've got a band at the one end that goes in the direction of power. So these 12 are okay, and these 12 are the wrong way around. Or is it? No, actually it's these 12 that are the wrong way around and those are right. So on the back, I brought all of them from the terminal block, wired along through the diodes, and then I literally just joined them all together to a red and black. So what I'm going to have to do, I think, I can unsolder these, that'll be easy enough. But I think then I'm just going to have to melt this and pull out the ones that are the wrong way round and redo it. Build a model railway, they said. It'll be fun, they said. Tell you what, I'm really pleased I've put more sockets under here than I need. Because when I've got the board tipped up like that, the socket is beyond the board. Because that's there, I can plug in what I need to plug in, and it all works. It's amazing. Right, I need to have a tidy up, so I've got some room to work. I'm going to leave this experiment set up because when I come to try and test this out and are the LEDs on in the right places, I can use the frog wire to power the individual wires I have on here to set up my LEDs, I think. So it's all connected at least. Now I probably will have to swap some of these wires around to get the LEDs to work, but so this board now has got the extra resistors and diodes, and all the permanent LEDs are going through here, and the ones for the turntable direction polarity will go through there. These are all the black wires and these are all the green wires. So I don't know what I've got to swap around yet, but what we're going to do now is test it. Okay, we've got the LEDs wired, we've got DC power into the control panel, we've still got a motor set up with DC power, and we've got this green wire from terminal 3 of the point motor that I'm going to put into these 12 terminals, which, if you remember, were the wires, the terminals for the frog wires to come in from all the points. So we're going to do one at a time. So I'll plug in my controller. That'll send power, DC power, to the layout, and not to the layout, to the point motor and the board, the control panel, and see what happens. Where's the fire extinguisher? Right then, here goes. Let that boot up. Wow. Okay. So these are the obviously the permanently on ones. Yeah, I want that one. I want that one. I want, yeah. Bloody hell. Wow, first time. Okay. They're good. They're working. This one and this one, they're the ones in the double slip. And as I've said before, a double slip is basically 2 points back to back. So all that's doing is it's just highlighting that there's a bit of track there, really, because that technically that piece will always be on. Wow, right, okay. So let's test the first one, which is what would it be? I don't know actually. Yeah, I'll do. It'd be the lights for 0.100. Let me put this in so that it doesn't keep falling out. Right, 0.100. So that has come on. So if I power the point motor now, that should go off and that should go on. It works. I suppose, of course, I might still have to swap the wires round, because if the point was now actually opening up this road, I'd have to either swap the LEDs round or swap the wires round at the back. But do it back the other way to make sure it wasn't a fluke. Cool. Right, let's try the second one. So this would be 0.2. 0.2. So that should be one of those. Why is there no light on? Is that wiring probably? Yeah, all those are in. Okay. So 0.2. Both the green wires. I think they might be in the wrong terminal. Just bear with me. Are they? 0.0, 0.1, 0.2. No, they should be right. Okay, I'll have to do some investigating on that one. We'll flick the point motor and just see if the other one does come on. No. Okay, 0.2 I need to do something about. Let's have a look at a scrap piece of paper. 2, no lights. Okay, let's have a look at 0.3. No, that'd be actually, that would be 0.1. Let me think for a minute. That's 0.0, 100. 0.1 would be the next one, so this one. So it should be one of those lights that's on. Okay, I'll have to have a think about that and come back to it. So let's try 0.2 now. Okay, so we've got one on. So that one has just come on. So if we flick point motor. They've switched. Right, 0.3. So yeah, that one has come on. Let's flick it the other way. Oh man, that's 3 out of 4, no, 2 out of 3. Right, let's try it. So which one's this now? 1, 2, 3, 4, 5. So, no, so this should be 0.4. Where's 0.4? There. We've got neither light on. Go back the other way. Nothing. Okay. Number 4. No lights. Number 5. Okay, number 5, so that one's just come on. So we'll go back the other way. Yeah. Number 6. Okay, this is number 6, and that road is just lit up. So back the other way. Hey. 7. What happened? Oh yeah, there we go. Yeah, it's 7. What is that? Okay, so number 7's come on that road. Back the other way. Another one. Yep. 0.8. So we've got one road lit up on 0.8. This is getting good, isn't it? Oop. 0.9. So that one's just lit up. Oh. 0.10. Oh, 0.10. That's not right. We've got a line off 0.10 and a line off 0.11. So I've obviously got the wrong green wires together, I think. Let's just go the other way. Yeah, I've got them wired up as a set somehow. So 0.11 and 10 joined. And then, what's the last one for? Why have I got an extra? Oh, I see, right, okay. So 0.10 and 0.11 on here, because they're joined at the back, I'll get the same result whichever wire I put it in. I don't remember doing 0.3. It's 1, 2, 3. That's 0.2. Is it? No, 0, 1. Yeah, that's 2. Right, 0.2 works. So 0.4. 3, sorry. Yeah. 4. No lights, we've got that on the list. 5, that one works. Right, so I've got 0.2 and 0.4 and nothing's working. I suspect that's because the green wires at the back will be joined to the wrong wire off this block, so I can sort that. And 0.11 and 0.10 are wired up together somehow. So I need to sort that out. But wow, it works. That's absolutely fantastic. I'm not going to bore you with swapping them around. I've explained enough times now how it's wired up. That's just something I've done. It's a bit fiddly at the back there, so I can sort those out. Okay, guys, I've worked out that I haven't actually got wires wrong at the back for the ones that aren't working, other than 0.11 and 10. It's actually 0.11 and 12. Because I started at a 0, I should have started at a 1, and then it'd have been easier. But anyway, yeah, so 0.11 and 10 on here, I've got to sort out because they're working together, right? But up here, the ones that we had a problem with was actually 0.101 and 0.104, which is 1/2 of the double slip. And the reason that no LEDs are coming on when I operate those is because I didn't put any LEDs in for them. Yeah, the reason being, if we take 0.1 here, 0.101, the 2 LEDs on the rows off of that point are this one here and this one here. But those LEDs are controlled by this double slip here and this point here. I hope that makes sense. In fact, I'm going to bring you closer so that you can see. So this is point 101, one of the ones that no LEDs came on when I operated the point. And that's because this LED is controlled from this point, and this LED is controlled from this one. The same with number 4, which is here, 104. This light and this light don't come on when I operate the switch, and that's because this light is controlled by this point and that light is controlled by this one. So I have a decision to make, because as that is now, I think it's going to lead to crashes, if derailments and all sorts of things, if I leave it like that, because I'm going to look at the lights and say, yeah, that's a safe road, and it isn't, because I haven't flicked one of the points. One of the points could be the wrong way, because that point doesn't have any LEDs associated with it, and therefore if I only look at the control panel, I wouldn't know which direction that point is. So I've come up with two solutions. The first one is add extra LEDs, so that I have to flip the point to get the route all green. And I do have enough resistors and diodes, because when I was wiring it up, I was thinking, I've got spare terminals here. Why have I got spare terminals? I thought, well, carry on. And that's why. Because although there's 12 points at the minute, there's only 20 LEDs. The other way of doing it would be I wire the LEDs in series, so that if I've only selected one of the points to make the route, the LED still won't come on. I've got to physically switch the other point as well to make a circuit for the LEDs. And I think that could be the best thing to do. Because I don't particularly want to make the board a lot bigger to fit extra LEDs. And it's more wiring, and it's more faffing about at the back here. Whereas if I've got to wire up, I think it would be 4 LEDs in series, so that's 2 connections I've got to make basically, and it will be the green wires joined together, will it? The green wires are coming from the resistor. No, so it would be green and black together. I'll have to work it out. I'll probably do a little experiment again to work out how I've got to do it. So there might be another video yet. part 4 or 5. Yeah, so we might have to do another one on that. Wiring the LEDs through a resistor, so that they come on in series when 2 switches, so they come on when 2 switches are operated. Well, I think, guys, the way the video's gone, the way the progress has gone, I think I'm going to call this video a day, because we've got at least 2 more videos to come. Obviously, we've got the video on making these LEDs work in series, if that's the way I decide to go, which I think it is, and We've also got the potentiometer to fit and wire up with a double pole, double throw switch. So that could be a video on its own. So I think that's how I'm going to do it. But I would be interested in your comments on how you'd resolve that. Would you add extra LEDs, or would you wire them in series like I'm leaning to? The wiring I'd have to work out though. So if there's any nasty surprises that people know about trying to wire these LEDs in series, please let me know. Because I think that's going to be the safest way to operate the trains. You know, it's sort of foolproof as long as the system's working okay. No LEDs have failed or something, it's a foolproof way of doing it. So thanks very much for watching. Oh, and I just want to say thank you to all of the new subscribers. The channel's grown nearly another 100 subscribers since Friday or Saturday, so amazing. Thank you very much, and if you haven't subscribed yet, please do, and see if I ever finish this control panel. So thanks very much. If you've enjoyed it, give it a thumbs up, and I'll see you next time.